And he said that he will be sending mail.
Okay, okay. Vigneshwaran, Vijay,
Yes, sir.
Vikas,
Present, sir.
Vivekanand, Yadav,
Yes, sir.
Yuvraj. Okay, there are several absentees today. I just confirm Hasan is not present and Prabhakaran, Titus, sorry, Vallis. Then we have Vigneshwaran, Vivekanand, Yuvraj. Okay, there are 6 absentees. Are there any reason yesterday I confirmed with you about today's class, right? So if there are any conflict of timing, you should have informed me.
No, no, sir. Valish was stuck somewhere else. It's not
Yeah,
able to.
Vallis I know, but I don't know about others.
Asan and Goria is having some problem with the meeting was extended still now. So he said he's not able to attend today. That is the message I received from Goria. Rest of the people I don't know, sir. I think the engine people who are Vignesh, Vivekanand, Babaran are all. I think some maybe meeting may be extended. I think so. That is what the problem.
Okay. Now, why I asked is today I want to wind up. If you are not there, I would have extended, I would have scheduled it on some other day where all the people are available. So I don't want to schedule on a day where most of you are not available. That's the reason yesterday I just checked with you and you all said yes for today's class.
Sir, I'll check, sir. You can continue, sir. I will pull everybody. I think they missed out.
Okay, fine. So based on your consent, I had a class. Okay, I fixed the schedule,
Correct.
today's schedule. So I hope there is no, I mean, information in terms of information, I think it is reached well, right? That's what I wanted to confirm.
Yes, yes, sir.
There is no lack of information which people missed, right?
Yes, sir. Communication clearly given to everyone.
Okay, fine.
Yes, sir. Yes, sir. And regarding Wallis, he had a sudden, some sudden exigency. So he got
Now,
unplanned meeting.
Wallis has written an email to me, but I haven't heard from other people. Other 5, there are 6 absentees, right? Other 5 people, I don't know. Anyways, it's fine. So I would suggest them to check with you people who have attended the class to get the contents. Okay. So welcome back. Yeah, welcome back. We have 2 short chapters. I will wind up today with this 2 short chapter. Chapter 7, I'm going to start with. Chapter 7 is about instrumentation for pollutant measurement. So far, we discussed about in the emission module, we discussed about the mechanism at which the pollutants are formed in SA and CA engine. We discussed various factors that influence pollutant formation. We have also discussed in the previous class control methods, pollutant control methods in cylinder and after treatment control methods that are available to reduce the pollutants. So our focus so far in this module has been on the primary pollutant, which are having health hazard. Okay, these 4 species. Now in this chapter, what we are going to look at are how we can quantify this pollutant level, meaning in the exhaust line, we need to know how much of concentration of pollutants are emitted. So to quantify this pollutant levels in the engine exhaust, we need to get familiar with the principle followed, measurement principle followed to get this pollutant concentration. Also, we need to know what kind of instruments or equipment that we can use to measure these 4 primary pollutants. So it's very important. I think it is a routine activity to check the level of pollutants in the engine exhaust. Okay, it's an important activity. So we need to get familiar with this instruments that you need to have to measure these 4 pollutants and what are the measurement principle followed to measure the pollutants. So here we have this carbon monoxide, argon hydrocarbon, oxides of nitrogen that include NO1, NO2 and smoke. So Smoke will give a measure of soot concentration per unit volume of exhaust. Already I have discussed briefly about the dilution tunnel that we can use to get PM, particulate mass. Particulate mass measurement is done with the dilution tunnel. If you recollect, I have, when I discuss about PM formation mechanism, I briefly discuss about this dilution tunnel. When we define the particulate matter, what a particulate matter is based on the definition given by US EPA, I discuss about the dilution tunnel that we need to use to get the particulate matter. So dilution tunnel can be used to get PM mass, particulate mass. Okay. So we are going to see here this 4 primary pollutant measurement method. Let me start with CO, carbon monoxide. So you have a spectrum here on the left-hand side. That spectrum here, it shows the transmission of IR radiation and then absorption of IR radiation at a particular wavelength for CO. So what is important here, or what forms the basis principle here to measure CO is, different species in the engine exhaust. Engine exhaust consists of several different species. This different species absorb infrared radiation at a particular wavelength. CO has a very strong IR absorption at a wavelength range of 4.5 micrometer to 5 micrometer. That is what you are observing here. This is not meter, it's micrometer. So 4.5 to 5 micrometer is a wavelength absorption range of CO. So if you send IR radiation in this wavelength, CO is going to absorb that IR radiation. It is going to transmit IR at other wavelength, but it is going to absorb IR radiation in this wavelength. So CO, carbon monoxide, has a strong IR absorption characteristic at this wavelength range. This can be taken as an indicator to get the concentration of CO in the engine exhaust. That's what we are doing here in this measurement apparatus. We send IR in this wavelength range, and based on the absorption of IR, we can get a measure of CO level in the engine exhaust. So this is an apparatus that measures CO based on these principles. So principle involved is NDIR, that is non-dispersive infrared radiation method. So we have 2 IR sources here, infrared sources here, and they pass in parallel paths, as you could see here. During the travel, one of the IR pass through a reference cell which is filled with nitrogen. Nitrogen won't absorb infrared radiation in this wavelength. The other end, we have a sample cell. The sample cell is filled with engine exhaust gas. Based on the CO concentration in the engine exhaust, the IR is going to be absorbed because we are sending IR in this wavelength range wherein CO has a strong absorption characteristic. Okay, and the other end, we have a detector. The detector is a constant volume chamber divided into 2 equal volume by having a metallic diaphragm at the center. And this detector is filled with pure CO. So you have CO filled in here. At the middle, you have a metallic diaphragm that forms 2 equal volume chambers. Now you have a chopper here. This chopper will block or unblock the IR radiation. When the chopper blocks the IR radiation, the pressure in the 2 ends of the diaphragm are same. The diaphragm will resume a neutral position. Okay, it will remain in a neutral position. Now, during operation, this chopper will unblock IR radiation. So you have one of the IR passing through the reference cell. The IR is unabsorbed. Its intensity or energy levels are high at this end. The IR from the other source is allowed to pass through the sample cell wherein you are filling in this cell with exhaust gas. Based on the concentration of CO in the exhaust gas, you could see here that there is a reduction in the IR energy as it passes through the sample cell because it's being absorbed here. So you have different energy levels of IR coming from the 2 different sources, and this reaches this detector due to difference in the energy level of IR in the 2 ends of the equal volume chamber. You could see that the metallic diaphragm deflects. The difference in energy level creates a pressure difference. Okay, pressure difference, and because of the pressure difference, the metallic diaphragm deflects as shown here. The deflection of the diaphragm with relevant to a fixed probe will change the capacitance in an external circuit, thereby it produces an alternative current signal, AC signal. So you are detecting that AC signal, that signal strength is proportional proportional to the difference in the IR energy level in the 2N, which in turn is proportional to the IR absorbed here, which is related to the CO concentration in the engine exhaust, because CO alone is going to absorb IR in this wavelength range. So what we do here, this electric signal you get as an output is calibrated in terms of CO level in the engine exhaust. That is how you get the measure of CO concentration in the engine exhaust using this MDIR method. So this method can be used for CO. It can also be used for CO2. It's more suitable for single component species. It cannot be used for detecting HC, because HC, you know, it's not one species. You have 100 to 400 species of hydrocarbon in the engine exhaust. These different species will have different absorption spectrum. So you cannot generate IR over a wide range of experiment and measure all the hydrocarbon in the engine exhaust. So this is recommended single component species like CO or CO2. Unburned hydrocarbons are measured by using flame ionization detection method. Okay, the measurement apparatus is shown here. What you have here is a burner that produces a diffusion flame, high temperature diffusion flame. I say that this flame is diffusion flame because you could see here that the fuel is coming here, air is entering here, fuel and air are mixed at the ignition point. That's why this flame generated here is a diffusion flame. Right, so the fuel used here is hydrogen. You know, hydrogen flame do not produce any ion, okay. But once you introduce any organic substance like hydrocarbon, okay, once you introduce an organic substance like hydrocarbon to this flame, ions are generated here, carbon ions are generated here. So what we do here, we are sending sample here refers to exhaust gas tapped from the engine exhaust light. So a fixed volume of exhaust gas is drawn through this line, and it is allowed to pass through the tube where you are also allowing fuel. So the gas, exhaust gas, along with the hydrocarbon reaches the flame. Once it reaches the flame, it forms positively charged carbon ion. What do you have closer to the burner? There are two plates. These plates are called collector plates. Okay, they are subjected to an external electric field. Because of that, you could see that the plates are maintained at different polarities, positive and negative. Now, once you generate positively charged carbon ion, okay, here in the flame, positively charged carbon ion will migrate towards negatively charged plate. The migration of ion towards the plate will generate something called the ion current. So your migration of ion is resulting in a current in the external circuit referred as ion current. The strength of the ion current or the magnitude of ion current is dependent on how much of hydrocarbon is burned here. Okay, so basically you are correlating this strength, signal strength, with hydrocarbon concentration in the engine exhaust. Basically, it's a carbon counter based on the number of carbon ions that are generated here. The strength of the ion current is going to be dependent on. We correlate this with the hydrocarbon concentration in the engine exhaust. So that is how we get a measure of unburned hydrocarbon in the engine exhaust by using this flame ionization detection method. Next, we have oxides of nitrogen. You know, in the oxides of nitrogen, we have.
Sir, on the HCs, will we be in a position to find out which hydrocarbon it is? Because
no, we cannot find out the type of hydrocarbon. It's only total hydrocarbon concentration you will get.
Okay.
So this cannot detect the type of hydrocarbon. What we get as a measure of total hydrocarbon, we are going to get. We are not going to. I mean, this equipment is not able to distinguish between the type of hydrocarbon.
Okay.
For that, what you need is FTIR, Fourier transform infrared equipment is required to detect the type of hydrocarbon. For example, how much of saturated hydrocarbon or unsaturated hydrocarbon is present. You need to go with a different method. But FID is, with respect to your emission mandates, what we are presenting is only total hydrocarbon. Okay, that's why FID is a recommended method. Flame ionization detection is a recommended method to get HC concentration.
Thank you, sir.
Okay, so here oxides of nitrogen, you know, here we have two oxides, NO and NO2 in the engine exhaust. NO2 levels are high in CA engine, as we have already discussed. In SI, it's less than 3%, it's negligible, but it is not negligible in diesel engine. So we need to get a measure of both NO and NO2. The principle followed here is referred to as chemiluminescent. What is chemiluminescent? What is the meaning of that?
The component illuminates and
It is similar to what is happening in tube light, right? So
Tube light. Also, what is happening? Light emission, right?
ionization of the.
No, it is. Is it ionization or light emission?
light emission, light emission.
Light emission, right? It's a chemiluminescence. Luminescence referred to light emission. So basically, here it refers to light emission. When I say chemiluminescent, it's a chemical reaction that is leading to light emission. That is what is this terminology mean? Chemiluminescent. That is a chemical reaction happening. Because of that chemical reaction, there is a light emission. Okay, light emission follows the chemical reaction. Now, what is that chemical reaction? The reaction is between NO and O3. O3, you know, it is ozone. So the reaction between NO and O3 will result in NO2 formation in an excited or unstable state. That's why I put with a star with O2. So NO react with O3. O3 is ozone, and form this NO2 in an excited state or unstable state along with oxygen. Now this NO2, which is in an unstable state, will try to reach a stable state by emitting photon, which is nothing but light. So this is a chemical reaction happening between NO and O3. And because of that chemical reaction, there is an emission of photon, which is nothing but light. Okay, and what we have here in this equipment, this is the equipment that we have based on this chemiluminescent principle. This is where the chemical reaction is taking place. The reactor, chemical reactor, is shown separately in the second sketch on the right-hand side. So this is a chemical reactor where this chemical reaction is happening between NO and O3. So you need to generate O3. You have a ozone generator that generate O3 from oxygen. So air has oxygen. Oxygen plus O will give you, O radical will give you O3. O radical is generated by discharging electric potential. Okay, O2 will dissociate, form O. That O and O2 combine and form O3. So you are sending O3 here and you are sending NOx here. Okay, but the reaction is between NO and O3. I will come back to that. So you have, based on this reaction, so this is sample in, which is exhaust gas, which include NOx, and this is O3. These two are sent to the reactor. Okay, it's mixed well here using a fan, and chemical reaction takes place. Because of that, you have photon emitted due to the chemical reaction that is detected by having a photo multiplier tube. You know what a photo multiplier or a detector, photo detector will do? It will take photon and emit electron. So you will finally get an electric signal, right? And the strength of that signal is proportional to NOx concentration in the engine exhaust. Okay. So you also have something called a ozone scrubber. You need to remove ozone. Already we discussed that ozone is also a pollutant, right? So you have to remove ozone before it is sent out to the surrounding ambience. So the reaction is between NO and O3. Then how do we get NO2 concentration? For that, what we have here is a NOx converter. What this converter will do is it will convert all the NO2 to NO. So this is basically a dissociation reaction. Okay, so you know, for the dissociation reaction to happen, you need to maintain a high temperature. The temperature required is around 315. So this is what is maintained. This is the threshold temperature at which the NO2 dissociation is happening. Thereby you are forming this NO. So what we do here, when we allow sample to flow through the NOx converter, basically it is converting all the NO2 in the exhaust to NO. And then the total NOx is going in here to the reactor, chemical reactor, where NO, whatever NO2 present in the exhaust is also now converted to NO. So you have that NO, which is represent both NO and NO2. react with ozone and emit light, and that is detected using this multiplier. And based on the signal strength, you can correlate that with the NOx concentration in the engine exhaust. Okay, so now there is a question to you. If I want to get the measure of NO2 alone, how can I get? If I want to get how much of NO2 is present in the engine exhaust, how can I get that? Just by looking at this apparatus, you can tell what we can do to get the measure of NO2.
By tracking what is happening in that converter, I mean, um,
So we can track the number of photons emitted, and we can
Number of
get the-
photons emitted is a measure of total NOx. Okay, because already you have converted all the NO2 to NO here, and then you are allowing NOx, I would say. So whatever NO2 present in the exhaust is already converted here to NO, because the chemical reaction is between NO and O3. So
How
we
much
get
of-
a total measure of NOx when you allow through the converter.
How
But
much
what
of
I want to
energy,
know is NO2 alone.
how much of energy we are injecting to convert NOx to NO2 to NO through that value will be in a question maybe.
No. Okay, so there is a bypass line here. Can we do something with this?
Sir, I was about to say that only. Like bypass, if I close, suppose
Hmm.
if you close the
So
bypass,
if you close this valve, allow the exhaust to flow through this bypass line, what will happen?
then NOx conversion will not be there.
NOx conversion, not NOx conversion, NO2 to NO conversion won't be there.
Yes,
right?
yes. That's
Okay, then what will happen? What are you measuring then?
Then what-
The fall in the intensity or something like because then the in the
No,
photo multiplier tube.
my question is simple. If you allow the sample to flow through the bypass line, what you are measuring?
NOx,
Then-
NO, quantum of
Then
NO, quantum of NO alone we will be measuring.
Yes.
NO2.
Exactly. So you are measuring NO alone because you are not converting NO2 to NO. Okay. So if you allow sample gas to flow through the bypass line as indicated here through arrow mark, what you are measuring is only NO. If you allow the sample gas to flow through this line, closing the bypass line, what you are measuring is NOx. Okay. So NO2 will be equal to total NOx.
Right, sir.
By closing the converter or operating the converter, you can get a measure of total NOx or NO alone. By doing this, you can get a measure of NO2 present in the engine exhaust. Because it's also important to track how much of NO2 is present in the exhaust and how much of NO alone is present in the exhaust. I already told you that NO2 level in the exhaust is a function of engine operating condition like load. Okay, at low load, you will have a high NO2 concentration in the diesel engine, because that reverse reaction won't happen. Reverse reaction in the sense conversion of NO2 to NO doesn't happen at low load. So you need to track the values of NO2 to NO. In fact, NO2 is also more harmful for the human health. So when we measure the engine exhaust, we should also track the value of NO2 as well as NO. So this is how we do. That's why we have this bypass line. Okay. Next, we have smoke measurement. Actually, particulate measurement is very expensive. That's why we do with measuring smoke also sometime, which is a simple, it's relatively a less expensive equipment. And this gives a rough estimate of soot concentration in the engine exhaust. So when I say I'm measuring smoke, what we get as a measure of smoke is a soot concentration per unit volume of the exhaust. Okay, soot concentration per unit volume of the exhaust, mg a gram per meter cube of exhaust. Okay, this is what we get. And there are two principles, measurement principles followed. One is the rough method, it's a Bosch smoke meter. The other one is relatively accurate. It's a Hartridge smoke meter. In Bosch smoke meter, you will get a measure of smoke in terms of filter smoke number, FSN. Filter smoke number. This will be in a range of 0 to 10. 10 is a very high level of soot in the exhaust. 0 is nothing. You have a clean without any soot particle. Okay. The principle involved is you could see that we are drawing a fixed sample of exhaust through this line. A fixed volume of exhaust is drawn through this line. Okay, to create this flow, what you need to do here is a pressure drop. Okay, to draw a sample volume of exhaust gas from the tailpipe to this equipment, you have to create a pressure drop. That is done by having a pump here. Okay, so when you move this pump towards right side, what will happen? The pressure will drop here, right? It's a vacuum pump.
Yes, sir.
So you are able to draw the exhaust gas by moving the pump towards right side. And what you have here is a filter paper of record quality, meaning it's a clean white filter paper that is fixed here. And you are drawing exhaust gas through this line, meaning that you are allowing exhaust gas to impinge on this filter paper. When you allow gas to impinge on the filter paper, which is clean white, based on the soot concentration in the exhaust, the filter paper is going to get stained. It will be stained more or darkened more when you have high level of soot in the exhaust. It will be darkened less when you have less soot level in the exhaust. So based on the soot level in the engine exhaust, the degree of darkening of the filter paper is going to be different. So what you do after allowing exhaust to impinge on the paper, you remove this filter paper and subject it to light detection test. Light allow light to pass on this filter paper. If it is a clean, if you have a scale of 0, when the filter paper is completely dark, you will have light absorbed completely. You know, black is a perfect absorber. Soot is absorber of light. Completely absorbed, you won't get any light reflected back. So you have a number assigned 10, which is the highest soot concentration. In between, you have different levels of numbers. That is how you have to calibrate this, okay, this scale. And this number reflects how much of soot is present in the engine exhaust. So that's why I say that it's a rough estimate of soot based on degree of darkening of the paper in a scale of 0 to 10. One of the more accurate or precise way is to use this meter, cartridge meter. You have a light source from an incandescent lamp. Okay, light from the incandescent lamp is allowed to pass through a standard length tube. This standard lens tube is filled with exhaust gas. On the other end, you have photoelectric cell that is going to detect the magnitude of light received here. The magnitude of light received here is dependent on the soot level in the exhaust. Because what will happen based on the soot level in the exhaust, the light is going to be absorbed. When you have a high soot level, more light absorption will take place here. Only less light will be transmitted. When you have a less soot, more light will be transmitted. So basically what we are tracking here is the light that is transmitted. That is what is measured here using a photoelectric cell. You know the length of the tube, which is a standard length tube. From this, this is called Beer-Lambert's law. So from this, what you get is K is unknown. K is absorption coefficient. K is expressed in terms of soot concentration in the exhaust. That will be expressed in terms of milligram per meter cube of volume of exhaust gas. Okay, so from T and L, you are calculating K, and K is correlated with the soot concentration in the exhaust. That is how you get a measure of smoke or soot concentration in the engine exhaust using this cartridge meter. Okay, so now we are moving to the last chapter, which is about emission standards and testing. Again, it's a short chapter. These are the contents that we look at in this chapter. There are two things here. One, what are the current emission standard that we follow? And so when I say we follow emission standard, what we have in the standard is some numbers, right, as we know. And these numbers are arrived at by running engine and vehicle in a specified test speed and test load condition. That specified or well-defined test speed and load condition is called drive cycle. So you need to take your engine and vehicle to a drive cycle in a special dynamometer called chassis dynamometer. Okay, and run engine or vehicle over a specified period of time at different speed and load condition. So how do we set the speed and load? The speed and load are set based on the actual driving conditions in a given country. So based on the road and the driving conditions in a given country, drive conditions are also different in city. It's different in a rural area. It's different in a highway. Okay. So what we do when we test the speed or load in a test cycle, we carefully fix the speed and load in such a way that we are able to simulate the actual drive condition. So we take vehicle to this dyno, simulate the actual drive conditions in terms of speed change and load change. Okay, and that will be incorporated here in the test cycle, right? By running vehicle over a specified period of time under this different speed and load conditions, simulating the actual drive condition, we are going to get the numbers in the emission standard. So from this information, you know that we cannot compare emission standards of different countries because the drive cycles are going to be different in different countries. Okay, so a quick recap of how we started following this emission standard. The first standard was introduced in US, more specifically in California in 1965. Then Europe introduced it in 1970. The rest of the world either follow European test cycle and European standard or US test cycle or US standard. India, we follow European test standards and test cycle. Okay, of course, with a time lag. So we follow European norms, emission norms with a typical time lag of 5 years. We are lagging behind actually by almost 5 years compared to them. Right, like I said, either European emission standards or US emission standards are followed by rest of the world because these people are pioneers in introducing emission standard. US introduced first with a 5-year time lag, Europe introduced. Okay, the rest of the world either follow US standard or European standard. We Indians follow the European standards. So this cycles are slightly different in different country, and based on this drive cycle, you arrive at the numbers in the emission standard. So we, what I want to convey here is we cannot compare the emission standard of different countries directly because of this reason, because the drive cycle could be different based on the country-specific drive conditions. So these are the different numbers. So the objective here is not to grasp this number, rather you just observe these 4 primary pollutant, how they are reduced over a period of time, right from 1992 to 2010. Currently from 20, you know that from 2020, we are following BS6. It is Euro 4. Euro 4 and BS4 are equivalent. Similarly, Euro 6 and BS6 are equivalent. As I said, we are following European standard and European cycle. Okay. With a time lag, okay, with a time lag of typically 5 years. So from April 2020, we follow Euro 6, which is in India, we call it as BS, Bharat Stage 6 norms. Okay, in metropolitan cities, in other cities, still the old norms are being followed, Euro 4 or BS4. Okay, and this values, you could see that it's almost reduced by 10 times if you look at the particulate emission from 0.36 to 0.03, it's almost zero level. These values are specified in gram per kilowatt hour if you have a heavy duty vehicle. In a light duty or medium duty vehicle, these values are specified in gram per kilometer. So the units are slightly different based on the vehicle category. When I say heavy duty, it's based on the gross vehicle weight, which is very high. And for them, it is in gram per kilowatt hour unit. For light vehicles with less gross vehicle weight, the unit is gram per kilometer. So these are the current norms. Euro 6 is, our BS6 is equivalent to Euro 6. So this is for light duty vehicle, NOx and PM standard. This is for heavy duty vehicle, NOx and PM standard. So we are here now, BS6. You could see a significant drop in the level of NOx and PM from Euro 1 to Euro 6, which is same as BS1 to BS6. In fact, we bypass BS5. From BS4, actually, we have moved to 6. We have bypassed BS5, okay, from 2020. Before that, we were following BS4, which is equivalent to Euro 4. So from here, Euro 4, we have jumped to Euro 6, which is BS6. Now you could see the level of PM and NOx, it's almost zero. Right, this is where the challenge is. We are now moving towards zero pollutant vehicle. Okay, although we say that there is a combustion happening in the engine, we want the pollutant level to be almost zero. We want to completely eliminate the pollutants. Okay. So these numbers, whatever you are seeing here, as I said, this numbers, typical numbers. So gram per kilometer is for light duty vehicle, gram per kilowatt hour is followed for heavy vehicle. So these numbers are arrived at by taking vehicles to a specified drive cycle. This is a typical European drive cycle, which we also follow with a slight change. I will tell what is the change. This is a European test driving cycle for light and medium duty vehicle. There are two drive patterns you could see. This is phase 1 of the test and this is phase 2 of the test. In phase 1, you could see that 4 repeatable patterns of speed and load are observed. This is called the 15 mode test, indicated as ECE 15. What are those 15 mode? You start with cold idle condition, then acceleration, cruise, deceleration, again idle, acceleration, cruise, deceleration, idle for some time, acceleration, cruise, deceleration, again cruise, deceleration, and then idle. So there are 15 modes. The vehicle is taken through these 15 modes. And this is basically to simulate a typical city driving condition. Max vehicle speed is less, as you could see here, well below 60. And so the engine is run continuously over this period of time, 780 seconds. Okay. And engine is run at this different speed and load condition. Basically, you are taking the vehicle to acceleration, deceleration, cruise mode, and idle mode. That is how you drive the actual vehicle also. As I said, this pattern is captured to simulate the actual vehicle drive conditions. Okay. And what we do when we run, this is repeated 4 times over this period of time. When we run engine over this period of time, the exhaust coming out of the engine, the pollutants are continuously measured by using analyzer. And what you have in the analyzer is an integrator. These are high response, fast response analyzer. They have an integrated circuit. They will integrate the pollutant concentration over this period of time. That is how you get the final number that you are seeing here in the emission standards. Okay, so now you run it continuously in phase 1 over this 15 mode, then take it to phase 2. In phase 2, you could see there is a different speed and load condition. The max speed is around 120 kilometers. This is basically a motor highway or highway drive condition where you run vehicle at a higher speed. Okay, in India, this max speed is reduced. Instead of 120, we have 90 kilometers per hour. That's the only change. The rest of the patterns are being followed in our Indian drive cycle. This is for light and medium duty vehicle. For heavy vehicle, you need to take it to 2 different tests. One is steady state test. The other one is transient test. Here, speed is divided by rated speed, and which is a normalized speed pattern. This is a normalized torque or load pattern. Torque divided by max torque, expressed in percentage. This is transient test speed and load condition. This is steady state test speed and load condition. So you have, and rest of the things have 3 speed and 4 load, 25, 50, 75, and 100. 4 load condition, 3 speed condition, 4 by 3, 12, plus 1, 13. So it's a 13 mode test. So this speed, you have 3 speeds here, N, A, B, and C. How do we set this? Suppose if you take this NA, this is estimated using this equation, 0.25. So this is for NA. For NB, everything is same except this number. This number will be 0.5. For NC, everything is same except this number, which is 0.75. Okay, and NLO is 50% of rated speed. NHI is 70% of rated speed. So you know what is the rated speed of your vehicle engine. So from this it is calculated, NLO and NHI. Okay, so this equation you are repeating for NB and NC, except that this constant is varied For A, it is 0.25. For B, it is 0.5. For C, it is 0.75. Okay. And NLO is 50% of rated speed. NHI is 70% of rated speed. So from this, you get a measure of these three speeds, NA, NB, and NC. So there are three speeds and four loads, 25%, 50, 75, and 100% load. So this is 12 mode at different speed and load. This is one at idle. Okay, so put together, this is called 13 mode test. So there is a steady 13 mode test that is done for heavy vehicle with high gross vehicle weight. Basically, the steady state test is done to capture extreme condition where the pollutant levels are high. So they want to take vehicle to extreme conditions where pollutant levels are high and see whether the vehicle is complying to that. Then in the transient test, this is the speed versus time. Here you have torque, normalized torque versus time. Okay, so there are three patterns here, each done for 600 seconds. So this is pattern 1, this is pattern 2, this is pattern 3. So you're running vehicle in a transient mode in three different patterns. The first one is city driving, second one is rural, third one is highway driving condition, where you could see there is almost steady condition, steady high speed. Okay, the max speed is around, the average speed itself is high, around 88 kilometer per hour. In the second phase, rural, it is somewhat high, 72. In the city, you could see that there is a frequent change in start, stop, acceleration, and deceleration. This is how you run your vehicle in a city driving condition, right? You often go to idle, you often start, stop, okay? And then even the number of signals in the way you drive is going to decide the start, stop, acceleration, and deceleration. So all these are simulated here. That's why it's a typical city driving condition that we simulate. This is associated torque variation in the vehicle. The first one is the speed variation. So basically we are capturing the typical city, rural, and highway driving condition when we fix the norms, emission norms. Okay, we measure the pollutant continuously over this period of time, integrate it. In fact, different weightage is also given for different phases of the engine test. So you integrate, you give weightage for different phases, and finally arrive at the overall value that you are seeing in this table, emission table. So this final number is arrived at based on the drive cycle, weightage, and integrating the values during the individual phases.
Sir, just one query on that rural part.
Okay.
Why is the speed a little bit higher actually? I thought when in rural it should be a little bit lower, but it is still at the average of 70 or
traffic congestion is less, right?
okay,
Compared
so
to city, in rural, the traffic congestion is less.
okay, so when we say rural, what part are we meaning? What kind of road condition? Like
Outskirts of the city limits.
outskirts. Okay, got it.
Okay, still people are there, but it's in the outer, not in the core area, city area.
Understood.
And then highway is further away.
Noted, clear.
Okay.
Prem in India also you can drive better in rural area compared to city.
Yeah,
Roads
I was just wondering.
suitable for any country.
Yes, the roads are very good now.
Yeah, yes. So it's all done. With this, I close this course. I will just show you a quick recap of our CLO, course learning objective. You can re-examine and see whether you have learned all this. So this is what we propose to learn from the course. Okay, understand the role of fuel in engine combustion and pollutant formation, underlying mechanism behind the combustion process and pollutant formation process in SI and CA engine, identify parameters that control combustion and pollutant formation in this 2 IC engine category, measurement principle followed, and instruments used for quantifying combustion. We discussed this in the first module, and pollutant measurement method just now we discussed for the second module. Then learn current emission standards and emission testing procedure. So this is what is proposed as the objective of the course. I hope you have learned this objective through this course. So with this, I conclude. If you have any questions, you can ask.
Just gratitude, sir. Thank you very much for imparting this knowledge.
Yeah, if you want to pass on any feedback also, you can pass on now. So it's time to conclude. If you want to pass on any information apart from your queries, whatever queries you have, you can always write to me. I will get back to you before the exam. Okay, so
No, sir, we thoroughly enjoyed your classes, and it was very the way you have taught us. It is really amazing, and the pace was so nice, and every bit of like the content we have enjoyed.
thank you.
And
Yeah, thank you
we are
for
thankful to you. And the second best part of the study was that your delivery of content was not like theoretical. It was very. It seems that a lot of practical knowledge, practical backup that you have, and you are telling it so confidently, sir. It was very great to learn all those things, sir. So
thank you.
thank you for this,
Yeah, thank you very much for your positive feedback. Anything else?
Sir, only one line. Like I'm from hydraulics background, so I did not have much touch with engine. But now I feel I have a connect with engine.
Okay, good. That is exactly the purpose of the course and the purpose of my teaching. So I want you to learn things. As I said, the marks or grades are based on how you do on a particular day. But what you learn at the end of the day, that's why I revisited the CLO, course learning objective. So the learning that you get for me is most important than anything else. So that is what I want to. So I'll be more than happy if you learn more, and if you could apply any of this in any of your work, routine work, or later on also. Okay, that is exactly the purpose of any course, I think, which is what is the case for me also.
Thank you so much, sir. Means uh, the way you plan the lectures, it is so meticulous. Like it is beyond our imaginations, and like, yes, sir. We are
So this is
really.
that is how I teach. Maybe for you people, it may be a new experience, but that is how I plan any of my course, any of my lectures. So I have just done my, I would say my duty, okay, which I'm supposed to do, right? I don't think anything extraordinary I have done. So I have just done my duty. If it has reached well, I'll be happy to see that that reach is good. That is the check I need to do. Okay, if the reach is good, I'm satisfied. That's it.
Sir, this is Sir Arunachalam here.
Yes.
This is the first time I'm seeing online course with handwritten PPTs.
Okay, so actually, I'm against using any electronic tools for any of my class. Basically, I prefer to use chalk and board for all my course. I use PPT to a limited extent because I don't want to spend time in drawing something, or if there are too much of content, I don't want to spend time in writing too many things. But basically, to me, only when you write, it will get registered in your mind. Our mind is volatile, right? So if we hear too many things, some will be there in mind, some will wipe off. It will go off after a period of time. But once you write, it will get recorded in your mind. So a very good practice of learning a course or learning anything is start writing yourself. Maybe
Exactly.
even for your daily routine, work routine, you just write what you have done. It will get registered in your mind. You could see the difference. Without writing and with writing, definitely you will see the difference. That's why I recommend you to take lecture notes. It's not about just hearing what I am saying for 15 minutes. Start writing. Once you start writing, it will get recorded in your mind. It will reflect in your performance, exam performance.
Exactly, sir. Sir, and one more thing also, really your valuation on our paper is really good, sir. Because most of the in my earlier days, most of the professor will see all the notes from A to Z. But your valuation is what we understand from your lecture. That only we evaluated. That is very helpful for us, sir.
Yeah, as I said, for theory part, the learning, whether you got the message or not, whether you understood the concept or not, is what I need to check, right? More descriptive answer is not at all required because we always run out of time. We have a limited time, especially during quizzes. That's why I stress on that part. I don't want any elaborate answer. Okay, and the same question you can give multiple answers. That is also fine. So you should think in different dimensions, not only the way I give. There's no need to write exactly the same way what I taught. You can imagine in a different way. You can write and bring out the same concept in a different way. That is also fine. So in fact, we should encourage that. Your thinking ability and the outcome of that is more important.
Yes, sir. Thank you very much, sir. Thank you very much for your.
Yeah, thank you. So I appreciate your view of your positive feedback. I hope it will be helpful for you. This course will be helpful for you. If it is helpful, I'll be more than satisfied if it reaches you well and if you could utilize any of the learning in anywhere.
It has given us a different perspective, sir. It's very nice, actually.
Thank you, Roshan. So Yuvraj has raised a hand. You have something to say? Yeah.
Yes, sir. So, I raised hand for thanking you only, sir. Actually, in our bachelor degree, we have learned only the basics of engines. We never learned in depth of engines. What we know, we only know what are the four stops. But inside the engine, so many things are happening within fraction of second. That actually I've learned from this class.
Okay, good to know.
That is one good thing, sir.
Okay, thank you. Good to know.
I think all the questions are
Okay, so there is a lot who else? I just repeat name. Vivekanand.
Present, sir.
Then we have Vigneshwaran.
Vignesh, already maybe missed out.
Vignesh is not here. Valish.
Malish also not there.
Okay. And then Prabhakaran.
Prabhakaran is there.
Prabhakaran. Is he present?
Yeah, he's present, but Mike, yes, sir.
Okay. Hasan.
Hasan not joined, sir. He was stuck in a.
Okay, fine. Okay. Okay, that's all I have. If you have anything more to say, I will wait. Otherwise, I will close here. And all the best with your exam and your career, future career. You can contact me any point of time for whatever help you need. And before the exam, if you have any questions or doubts, you write to me. I will get back to you. So you have to go through the entire syllabus. And as I said, the weightage will be given for the contents. More weightage will be given for the contents that are discussed after quiz 2. That is to ensure a fair distribution of marks across different contents for the course. Okay. Prem Vinayak has raised the hand. Yeah, go ahead.
Sir, just a small query on that remaining notes part also.
Yes, I will send it. Whatever I have, what I am yet to send, I will send it soon.
Okay, sir. Okay. Yeah.
Check what is the previous one I have sent to you. I think last week I have sent the material.
Yeah, so I think 35 we have got, so till 35, lecture 35.
35. Okay, the rest of the thing I will send it soon.
Okay,
Today.
sir. Okay. Thank you. Yeah.
Fine. Roshan has raised a hand. Yeah, go ahead. You are muted.
Sir, I have one request from our side, that what is your feedback on our batch, sir? Actually, that is also important to know from your side.
So your batch, the positive thing I could see is your involvement for the course and your interest for the course. Your interest and involvement, I see it's very good. Because I know how difficult it is at the end of the day to follow up with any course or any lecture. It's end of the day's work for you. At the end of the day, you sit, listen, showed interest, showed involvement. These are the positive things I see from your batch. And first quiz you didn't do well. So I expressed my unhappiness. Then second quiz you picked it up, and it was really a good drastic change, I would say, in terms of class average. From 14 it has moved to, I think, 20 plus. So so you have followed up what I am saying, which I like most. And also you have shown your involvement and interest for the course. Except few people, most of you are present all the time, all the day. So that shows your interest for the course, which is very important for me. I appreciate that. That is a positive thing I would say about your batch. I think you are the third batch for me for the online MTech course. So this is a positive thing I have noticed with you.
Thank you so much, sir.
Thank you, sir.
And
Sir,
sir,
sir, one last question, sir. Sir, this may be typical or generic question related to this subject. Occasionally, we must
who is speaking?
Anand, sir.
Anand, okay.
So occasionally, you might have read it across newspapers like accidentally diesel must have got filled in petrol vehicles and the engine got seized. So we have read it about it, but we would like to hear it from your expert opinion, sir. What actually?
But I have asked this question for some other batch. Whatever you are asking, whatever you are telling, I have put it as a
I would
question.
like to hear it from you, sir.
So you should comment. Now you have an understanding about diesel and gasoline. In chapter 1, we have discussed a detail, right? We made a detailed discussion about these two fuel that we use in SA and CA engine. If you, and you know the principle, combustion principle. So if you fill, say, your question is you have accidentally filled gasoline in diesel engine. That's right. So the engine won't even start. Gasoline is a high octane fuel. Diesel engine is a self-ignition based combustion. So if you fill high octane or very low C10 fuel, you know there is a minimum C10 required for self-ignition, right? Gasoline don't have that minimum C10 number. So the engine won't start.
that's a blessing actually, because reverse way engine will damage.
Engine won't even start, but with the compression ratio that you use, otherwise you have to go with very high compression ratio. In fact, I have said about we have run diesel engine in a alternative combustion mode. There we found that gasoline is a more suitable fuel than diesel. We could run diesel engine with gasoline in alternative low temperature combustion mode. In fact, we observed that diesel is not a suitable fuel. Gasoline is a suitable fuel for alternative combustion mode. We had a problem of ignition, whatever I said now, only at low load condition. What we have done is we have used ignition improver additive. One of the commercial additive is EHN, ethyl hexyl nitrate. So we could add up to 5% of EHN in gasoline. That helps in ignition. And then when we take it to the high load, gasoline started self-ignition. So once you have the required temperature level in the engine, gasoline also self-ignite. Okay, fine. So let me conclude here. Again, my best wishes to all of you for a great career. And before exam, if you have any questions, you write to me, I will get back. And
Sir, may I make one request, sir? If possible, it can be like video lectures that you have, few of the lectures you have shared with us also. So if you can.
Video lecture, the problem is some of my lectures could not get recorded. There are some issues with the institute Google license, right? So it is kind of random. Some are recorded, some are not recorded. But you asked about this in the beginning. I also said that as in principle, we don't share the lecture videos, but I will check if there is a possibility. Okay. But again, some of the lectures I could not record due to the issue of Google license. It's not continuous also.
No problem, sir. Thank you so much.
Okay. So your exam schedule, everything is clear, right? So you are coming, all of you are coming in person. Yes, collect your quiz 2 answer script that is with me, right? Any other questions or queries you have, you write to me. I will get back. Okay.
Thank you, sir.
Okay. All the best. See you during the exam time.
Thank you so much, sir. Thank you so much for your teaching.
Thank you, sir. Thanks a lot, sir.
Thank you so much.
It was unbelievable. Thank you so much, sir.
Thank you. I just anyways, species in the engine exhaust. Engine exhaust consists of several different species. This different species absorb infrared radiation at a particular wavelength. Presume a neutral position. Okay, it is absorber of light. completely absorbed, you won't get any light reflected back. So high compression ratio. In fact, I have said my lecture could not get
What means what
course. So with this, I conclude.